Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. So let's discuss some examples on circuit analysis using Laplace transform. Okay, let's look at the first example. The circuit shown is excited at t equal to 0 by voltage source of ET, and the capacitor is initially uncharged. By using transform methods, determine the current IT and the voltage across capacitor Vt for t larger than 0 when the source ET equal to 20 volt. Okay, so in this case, it is stated that the capacitor is uncharged, meaning that the initial condition is 0. Okay, so and then the source given as 20 volt. And okay, so you need to find what is IT and also the voltage across the capacitor, so Vt. Okay, for t larger than 0. Okay, so when t is less than 0, so the circuit is open, so there's no current flow across the components, therefore there's no the capacitor is uncharged and there's no initial condition. So in order to solve this, you need to transform the circuit into S-domain circuit. So in this case, the source ET become ES. So in this case, 20, when you convert into S-domain, it is 20 over S, and R stay as it is. And then the capacitor, you have 1 over SC. So your C equal to 1 over 8. So 1 over SC equal to 8 over S. And supposedly you have a series additional source of V0 over S. But since there's no initial condition, so this one is 0. So we can just simplify the circuit without having any additional source. Okay, so we can remove this additional source. So then don't forget to convert the I as well. So IT become IS in S-domain circuit. Okay, let's determine the current IT. So from the S equivalent circuit that we have developed earlier, so here ES is 20 over S, and then IS, this is 1 over SC, and then R stay as it is. Okay, so in order to solve this, so we know that the ES equal to IS multiplied with the total impedance. Therefore, your IS equal to ES divided by ZS. So what is your ES? ES equal to 20 over S divided by your ZS is the R in series with the capacitor in S domain, so it is 4 plus 8 over S. So next you need to simplify this equation and you'll get IS equal to 5 divided by S plus 2. Okay, so in order to get IT, so you need to perform inverse Laplace transform of IS and you'll get IT. So in this case, IT equal to 5 exponential of minus 2t. Okay, so make sure you refer to the Laplace transform, Paris or Laplace transform table in order to convert the time domain function into S domain, and lastly to reconvert the S domain function into time domain function back. Okay, next you need to determine the voltage across capacitor Vt for t larger than 0 and Et as earlier it is equal to 20 volts, so here is 20 over S, and then this is 1 over SC. Okay, so to get V S to get Vt, so you need to determine from Vs, in which you can get it from by using voltage divider. So Vs equivalent to Es multiplied with 8 over S divided by the total impedance 4 plus 8 over S. Okay, so you can simplify the equation, and Vs is equal to 40 divided by S plus 2. Okay, so what is your ES? ES is 20 over S, so you can replace your ES value here. Okay, so from here you can use partial fraction to get the parameter A and B, so in which Vs equal to 40 divided by S plus 2 equal to A over S plus B over S plus 2. Okay, so determine what is A and B, and then finally you should get A equal to positive 20, while B equal to negative 20. Okay, so finally you need again to perform inverse Laplace transform to get Vt. Oops. Okay, so Vt is supposed to be 21 minus A minus 2t, and don't forget the unit in volt. Okay, let's look at the second example. Given the coils of large horseshoe type of electromagnet used in a generator are represented by the circuit model shown in figure 2, and the switch is closed at t equal to 0. So you need to sketch the Laplace transform equivalent circuit at t equal to 0, meaning that when t is less than 0, there's no current flow in the circuit, therefore there's no energy stored inside the passive components, and the initial current or voltage are zeros. And then the second question, find the current I1t provided by the power supply after the switch is closed. So you need to find I1t when t is now equal to 0 or larger than 0 when the switch is closed. So now you have the complete circuit, and you need to use the loop current loop analysis to find I1t. The third question, after some time, so this connection occurs in the circuit at point B. So this is point B. So this connection occurs at point B. So you need to draw the new Laplace transform equivalent circuit, and please justify your answer. Okay, let's look at the first question. Sketch the Laplace transform equivalent circuit at t equal to 0. So you need to convert all components to S domain. So in this case, we'll be having the source and then at t equal to 0, now the switch is closed, and then you have the resistor, so R will be staying as it is. So, and then you have the inductor. There's no initial voltage, so you don't have to consider the I0. And then on the right hand side you have again another resistor and another inductor, and at the bottom another inductor. Okay, since there's no initial current or initial voltage, so you don't have to consider adding the additional source in series with the inductor. So don't forget to convert all components into S domain. So the source now is 100 ut, so it is 100 over S, and then you have R in T, so it will be R in S as well, so 5, and then L in T become SL in S domain, so your L is 5, so it's 5S, and then same to R2, and it is 5, and L2 become SL2, so it's 5S, and same goes to L3, so SL3, 5S. And don't forget to convert the current as well, so you have I1S, and in the second loop you have I2S. So this is the complete Laplace transform equivalent circuit at t equal to 0. So next you need to find the current I1t, provided that I1 not and I2 not equal to 0 after the switch is closed. Okay, so this is the circuit, Laplace transform equivalent circuit that we have drawn from the first question. So you can find I1t from I1s. So you need to perform loop analysis to get I1s. So from here, you mean on the left loop, we call it loop 1. Okay, so it is basically 5 plus the total 10s for I1s minus the shared one is 5 plus 5s I2s equal to the source is 100 over s. So this is equation 1. So next look at the right hand side, so loop 2. So you have a negative 5 plus 5s I1s plus 10 plus 10s I2s equal to 0. So this is equation 2. So please solve equation 1 and equation 2 to get final equation of I1s, in this case equal to, so this is the simplified step, so please make sure you derive equation 1 and 2 until you get I1s. So in this case I1s equal to 200 over s 15s plus 5. So as usual, you need to perform partial fraction expansion to get A and B. So this is equivalent to 40 divided by 3s, s plus 1 over 3, which is equal to A over is s plus b over s plus 1 over 3. So from here you should get A equal to 40 and B equal to minus 40. Okay, so includes the A and B values into the equation. So next you need to perform inverse Laplace transform. So inverse Laplace transform of I1s will produce I1t, which is supposed to be 40 1 minus e minus t over 3 ut. So this is your final answer. Okay, third question, after some time, so this connection occurs in the circuit at point B. So you need to draw the new Laplace transform equivalent circuit and you need to justify your answer. So from this first and second condition, So this is the Laplace transform circuit at t equal to 0 when the switch is closed. So now after some times, meaning that at t larger than 0, so disconnection occurs at point B. So the point B is somewhere here. Disconnection means the circuit is it's open at this point. So what happened when there's a disconnection at point B? Okay, so therefore after some times, meaning that at t equal to 0, there's current flow over the inductors. Therefore you need to consider the initial condition or initial current crossing the all inductors. So in this case, after some times, now disconnection occurs, so the source is 100 over S, and then you have the resistor stay as it is, and then you have the inductor, and then in series with the source, additional source, which is it is equal to Li naught. So what is Li naught? So I'll show you later on. And on the right hand side you have the resistor R2, and this connection occurs at this point B, and you have the inductor with the additional source in series. So again it is L2 I naught, I2 naught. This is L1. Okay, and then at the bottom you have another inductor in series with its source. Okay, and I is I1S, here is I2S. So our value is 5 and 5. And how about the Li naught? So here is still LS, L1S, so it's 5S. Same goes to this point, is 5S, and here as well. So here is L3 I naught. So here only dependent on I1 only. And at this point, since it's the sharing condition, so it's Li naught is equal to L is 5. So at this point it is I1 minus I2 naught, and at here is L2, so it is 5, so I2 naught. Okay, and here is 5 I1 naught. Okay, so this is the Laplace transform equivalent circuit when there's a breakdown at point B. Don't forget to justify your answer. So what happened after disconnection occurred? So first one, it's open circuit at the we can say right hand side loop, or at point B, and second, there will be initial values applied to the inductors due to energy storage inside the passive components. Okay, let's look at example 3. So an electrical circuit as shown in the figure consists of R1 and R2, an inductor, capacitor, and voltage source. The switch is closed for a long time before it is open at t equal to 0. So this switch is open. Okay, you can see the arrow. So t is open at t equal to 0 second. before that, meaning that at t less than 0 second, the switch is closed. Okay, so the switch is closed at t equal to 0. Okay, find the voltage across the capacitor. So across the capacitor, positive and negative. So VC T. And the current through the inductor when the switch is closed for a long time. So when there's a statement of for a long time, meaning that the circuit reach steady state condition in which the inductor and the capacitor may act as something else, okay, before the switch is open. Second question, sketch the electrical circuit by expressing the variables in Laplace transform when the switch is opened at t equal to 0. And then the third one, you need to obtain the expression of the voltage across resistor R1. So this is your R1. So you need to determine the voltage across resistor 1. So it's VR1 when the switch is open. And lastly, you need to determine the voltage across the resistor at t equal to 2 seconds. Okay, find the voltage across the capacitor and the current through the inductor when the switch is closed for a long time. Okay, so for when the switch is closed for a long time, so this is the condition where the switch is closed for a long time at t is less than 0 second. So when there's the switch is closed, so there's a complete path of the current flow across the passive components. Okay, so when the circuit is closed for a long time, the inductor may act as a short circuit while the capacitor appears as open circuit. Okay, so therefore, so this is the source, Vs equal to 10 volt, and then you have your R1 equal to 10 ohm, and the switch is closed at t less than 0. And then you have your resistor R2 equal to 3 ohm, and then R3 equal to 7 ohm, and you have the inductor when the switch is closed for a long time. In steady state condition, the inductor appears as short circuit while the capacitor appears as open circuit. Okay, so you need to determine the I across the inductor, so IL in the main loop. So IL0, and also the VC is VC 0. This will be the initial condition for the next state, in which after that, after t equal to 0, the circuit is now, the switch is open. So this circuit can be simplified as this one. So you need to determine what is the expression of VC naught and also IL naught. So from the loop, so VC naught equal to, so you can perform voltage divider. So it is from the source, so it's 10 multiplied with R2 plus R3, R2 plus R3 divided by the total impedance, R1 plus R2 plus R3. So it is equal to 10, 3 plus 7 divided by 10 plus 3 plus 7. So this is equal to 5 volt. And while IL naught equal to, so the source divided by the total impedance. So the source is 10 divided by R1 plus R2 plus R3, in which it is equal to 10 divided by 10 plus 3 plus 7 equal to 0.5 ampere. Okay, next question. Sketch the equivalent circuit by expressing the variables in Laplace transform when the switch is open. Okay, so the earlier state, the switch is closed at t less than 0. Now at t equal to 0, the switch is open, meaning that during t less than 0, okay, during t less than 0, the switch is closed. T less than 0, the switch is closed. So that's a complete circuit. So the current flow over the components, including the inductor and the capacitor. So that's energy. And later at t equal to 0, the switch is open. Okay, so there's already energy stored inside the inductor and the capacitor due to the initial state at t less than 0. So when the t now at t equal to 0, the switch is open. So there's no more source, and at t equal to 0, so the circuit can be simplified as this. So this is your R2, and then this is your R3, and then this is your L. So this question asks you to use Laplace transform when the switch is open. So this is LS. Okay, so L is 2 to S. So this is L I naught. Okay, so your L is 2. I naught from earlier question is 0.5. So it's 2 multiplied with 0.5. That's why you get 1. And then here is 1 over SC. And this one is V naught over S. So V naught from earlier calculation is 5 divided by S. Okay, next, obtained the expression of voltage across R1. So please make a correction. This is voltage across R2, VR2 when the switch is open. So at later state, you need to determine what is VR2. So VR2 is across here. Okay, so you can perform voltage divider in order to get VR2. So please make correction. This is VR2 or VR2. Okay, so VR2 is the total voltage multiplied with the resistor 2 divided by the total impedance. Okay, so in this case you get VR2 in S domain. So perform partial fraction in order to get the parameters A and B, and then finally you need to do inverse Laplace transform to get the VR1 in time domain. So because the question asks you to get VR2 in time domain, so this is VR2. Okay, last question. Determine the voltage across resistor 2 at t equal to 2 seconds. So from the third question, you have come up with VR2 equation. So VR2 from the third question, VR2 t equal to negative 0.5 e minus 4 t plus 2e minus t ut. But now the question asks you to calculate the voltage across resistor 2 at t equal to 2 seconds. So you just need to replace t equal to 2 in your equation. So e minus 4, 2 plus 2e minus 2. So therefore VR2 equal to 0.27 volt. Okay, with that I end the examples for circuit analysis using Laplace transform. So later I'll upload more examples, and you need to perform self-study solving the circuit analysis using Laplace transform. Thank you.